In this demo, I will walk you through a simple RAG system, which stands for Retrieval Augmented Generation. In this system, it contains three main components. First of all, the reference document, a vector index, and then we use Claude API here in this project to generate the answer. So as you can see, the pipeline for this project here, and our dataset contains 16 separate documents, and we have also qa.txt file which contain almost 100 sample question to evaluate our RAG system. First of all, we ingest all 16 documents and load each file. Then we did chunking by using recursive character text splitter. We use chunk size as 400 and overlap is 50. So this step is quite important because long documents are harder to retrieve from directly. So we use the chunking to get better result from the model, and the overlap basically preserve context in between neighboring chunk, and we did the embedding of that chunking in the next step. And we use a small sentence transformer model called all mini LML6 v2, and then we store the embedding in the FAISS vector index. And FAISS vector index have done the search the relevant chunk from the embedding based on the query user asked in the system. We set the retrieval as 4, so FAISS index retrieve 4 most relevant chunk based on the query and send that 4 most relevant chunk to the Claude API key to generate the answer. We selected Claude Haiku 45 20 25 101 model. This is the cheapest Claude model. So in this full pipeline, in the step 5 it cost money, and in the step 3 we did the embedding in our local machine because the embedding transformer model was quite small and the dataset was small. So you can run this step in your local computer. So this is the pipeline. So let's see the architecture of this project. First of all, you have to ingest the PDF or any file. Then we did the, in our case we ingest the CSV file. So then we did some cleaning stuff on that document, and then we did the chunking of the long text, and then we did the embedding of that chunk by using small transformer model all mini LML6 v2. Then we stored that embedding into the FAISS vector index, and then it searched the similar document, similar chunk, and retrieve for most relevant chunk and send that for most relevant chunk to the Claude API key to generate the answer. Yeah, this is the architecture and the pipeline we see for this project. And let's see how to set up the project. And once you clone this project from the GitHub, then you will find one folder on your local computer. Just open that folder on any code editor, for example VS Code or PyCharm you can use, and copy one by one command from here and paste onto your terminal, onto that code terminal. So first of all, this command what I am going to copy. So this command is basically create a virtual environment. Just put on your terminal and enter. So I have already created the virtual environment, so to avoid making this video too long, and then you have to activate that virtual environment by giving this command. Once you have see in your computer that .vnv or vnv in the beginning of this, then you can understand that your virtual or vnv is activated. For Windows user, you can use this command, and then you have to install all the required packages by giving this command pip install requirements.txt. I put all the required packages on requirement.txt. After downloading all the required package, you have to give this command cp.env.example space.env. then you will have one env file. So in my case, as you can see my cursor, so .env file I do have, so I put my Claude API key on this .env. So after giving this command, you will have one .env file in your folder. So I am going to show you .env.example. So in your case, it will rename to .env. So in this .env file, you will have to paste your Claude API key inside, like in between this comma. So it is very confidential, so do not share on any public repository or do not share to anybody. So after setting up all of these things, you are now ready to build this project. So first of all, you have to build the vector index by using this command, python build index.py. So I'm going to copy this command and paste it on my terminal. So before running this command, let's see what inside build index.py. So in build index.py, first of all, we load all the documents here. So if we see the load knowledge base document function, so here we store all the sentences, subject and document ID into the document list. So if we want to see the real data, so real data looks like the subject, document and sentence. The subject and documents are identical and sentence are different. So here first of all, we load all the documents over here. After doing that, we have to do the vectorization. So in this function, we did all these things. So first of all, we did the split or chunk of the documents, so by using this function. So first of all, we use recursive character text splitter. By using this function, we split the documents by using the chunk size 400 and chunk overlap is 50. So after doing this splitting, we save all the chunk into the chunks variable. Then we did the embedding of that chunk by downloading the Hugging Face transformer model. So our Hugging Face transformer model is all mini LM L6v2. And then after doing the embedding, we store all the embeddings into the FAISS vectors index and saved it into the vector store variable, and the vector store variable is saved in our local folder index.dir. So index.dir is basically output directory, it means, and then we named it into FAISS index. So after running this python build index.py, it will build the vector index of all the 16 documents and saved in to the output directory named with the FAISS index. So let's see what happened after running this. So I'm going to run this. Yep. So once you have like built the vector index, then we do not need to recompute the embedding every time unless the document is changed. So yeah, our vector index already created and it saved it into the document, into the output FAISS index file. So let's see, in the output we have, like, can you see my cursor? So here is my cursor. So here in the output folder we can see the FAISS index. Here it saved all the embedding in the FAISS index. So yeah, it already built. Now let's see what's the next step. So the next step is python ask.py question what is the subset of the population. So I'm going to copy this one and going to paste on the terminal. And before running this command, let me explain what inside ask.py. So let's see. So in the ask.py, we saved, like we load the saved vector and we load the Claude LLM and we call the answer question function and stored in the results. So let's see in the answer question function. So here we retrieved the chunk. So in the retrieve chunk, we retrieved the 4 relevant chunk from the embeddings. So after retrieving the chunk, we saved it in the chunk variable. Then in the response, we call the generate answer function. So in the generate answer function, we have the context variable. We saved all the chunks and we format the chunks by using this function. We formatting these chunks to help the Claude to understand more clearly, to retrieve more better result. And and saved all the formatted chunks to the context, and then we load the prompt template. So we just read here the prompt template. So in from the prompt file, so my prompt file is in the prompt.txt. so let's see the my prompt. So in the prompt.txt, if we give the word wrap, so this is the prompt: you are a helpful teaching assistant, answer the question briefly using only the context below, don't be verbose. If the context doesn't contain the answer, say there is a knowledge gap in the provided resources. Context, here we will pass the retrieved chunk, and the question is user asked question in the system, we will pass it. So here I also give on one command, don't be verbose, because Claude prone to answer, like generate a long answer. So we don't want to like a long answer in this demo. So to be more specific, I give more focused answer. I give this command to the Claude, and this is the prompt. And yeah, after loading this prompt template, then this is the prompt. We are passing the context, this context where we save our formatted chunks, this context to the prompt, and the user question to the prompt. This is our final prompt saved in the prompt variable. Then we call LM invoke. Every time we call it, it passing the final prompt to the Claude API key to generate the answer, and this answer will saved in the response variable. Then we will also show the resources, the relevant chunk we retrieve, and then in the this is the format, the output format. Let's see after running this command what will happen. Our question is what is the subset of the population called. So let's see. Yeah, we have the output. So question was what is the subset of the population called, and the answer is a subset of the population is called the sample. This is the retrieve relevant chunk, and yeah, that's the final output. And yeah, the next is, as I mentioned, we have also one file qa.txt where you can find almost 100 sample question. If you wanted to run all the question, you have to give this command and paste on your like terminal and run it. And just remember one thing, each question will cut the cost from the Claude API key. So yeah, that's the final rack system. That's the full rack system actually. And the data I have mentioned, we have 16 data document, and we have the qa.txt 100 sample question in that txt file. So this is our real output, we have already seen that. And yeah, that's the full rack system, a simple rack system you can build. And now I will show you like to run the one web application. And first of all, make sure your like VNV is activated, virtual environment is activated. So if it is not activated, just give these command, as I assume that you have already created your virtual environment in the beginning. And if you have virtual environment, just activate that. If it is not activated, for Windows user, you can use this command, just this command. And then after activated that virtual environment, you can copy this command Funix apps.py, because this application made by Funix, and just copy this command and paste on your terminal, and it will automatically redirect to your browser. Yep, I can see it is already open. So you will get this UI on your browser after running Funix apps.py. So in the UI, first of all, you have to enter your Claude API key into this input field, Claude API key. Then enter your question in this question field, and then give your relevant documents. These are my relevant documents. Yeah, these 4 files I have uploaded as a reference. And let's see after running this. Maybe let's see again, maybe there's some error in my API key, some spaces. Let's see what happened. Yeah, now we can see what Claude give the generated answer based on my question and the reference document. So based on the context provided, a sample is a subset of population, so the answer to fill in the blank is sample. So yeah, that's the answer generated by Claude based on my reference document. And yeah, this is the full rack project. Thank you for watching.